The standard normal distribution works exactly the same as the regular normal distribution, except it's a very specific version of it. It has a mean of 0, so it's always centered at 0, and it has a standard deviation of 1. What you'll find is that questions that refer to the standard normal distribution, you'll often write in terms of z rather than x. So how do we actually convert between our z and x? It's with this equation here. In an exam or SAC scenario, is going to be something like this. So let's have a look. X is a normally distributed random variable with a mean of 6 and a variance of 4. Notice that I said variance this time rather than standard deviation. Let z be a random variable with the standard normal distribution. Find b such that this is true. The thing that we know pretty much all the information on is the x thing, right? We have the mean, we can calculate the standard deviation by just square rooting the variance, and we know its probability of x being greater than 7. Right? We have our x, we have our mean, we have our standard deviation. We have everything we need for this left-hand side bit. What we don't have is the z-related information. Unfortunately, the way this question is worded, you can't necessarily just plug in those numbers and immediately say z equals whatever it ends up being. And the reason why is because these inequalities are pointing in different directions. The left-hand side is a greater than symbol, the right-hand side is a less than symbol. So one of the first things you want to do is make sure that your inequalities are pointing in the same direction. Well, we're going to draw up our normal distribution. It has a mean of 6, so it's going to be centered at 6. The probability we have is x greater than 7. 7 is 1 more than 6. And because of the inherent symmetry of the normal distribution, rather than go right 1 and then look right, we can go left 1 instead and look left. These are equivalent areas and thus equivalent probabilities. Now that they're directly comparable, we have our actual x value, we have our standard deviation, which will end up being 2 from square rooting the variance, we have our mean of 6, we have the 3 variables that matter when it comes to solving for z's. So just plug them all in into those spots, and what you'll find is that z comes out to be -1/2.